And this is an example as well. Someone has written automobile, someone has written automotive, someone can write auto. And then everything falls under automotive. Same for communication. We have comms, communications, communication and all those things. But everything falls under communication. Similarly for tech. So we know that this kind of a scenario can happen. So we need a process of consolidating our data into automotive communication and technology. So calculated dimension helps with this kind of an ask, whereby it helps us to culminate all the things together. Extraction. So we need to say, suppose we need another dimension from the first position of our media by name, which will help us to do some kind of an analysis. We see, like you know, high gear. Automotive analysis, car world. Maybe these as a dimension, will make much more sense with my measurement. And I want it as a single measurement which comes from the media by name. So calculated dimensions come into being, and it helps us do that. Classification. Now, if you have your web analytics site source, which comes with something called Yandex, Yahoo, Twitter, Instagram, Google, etc. And you want to classify your data into, say, search, social display, etc. Over here it's search and social only. So search and social calculated dimension helps us with doing these kind of work. So let's look at a logical condition that we have used an if and a lower, and let's see what case, what is the use case in which we are doing it. Simultaneously, we will see this in Datorama as well. So here we will see, like you know, how to use an if logical operator in a calculated dimension along with the lower text function, and why do we need it as well. So we have this right now, we have the campaign category automobile and automotive, which belong to the same campaign category. Right. So what we do is we go to calculated dimensions, we create a calculated dimension and then use the calculated dimension to get my set of. Get the set of things that I want. So campaign category needs to be uniform. So what we do is we go to the expression box and we go to if and the data was quick. Tip function is awesome because whenever you have selected one selected one function from the list. What it does is in the below field it gives the definition for it. So when you see the data over here, you see someone in caps, someone in small. Some have capital D's and some don't have. So what do you need to do? Is you need to harmonize. So what? I wanted all my data to be converted to a lower. Lower is nothing but a lower case, and using it along with, if so, what I do. I choose if and then lower. And what I want to classify is campaign category. Right, so I do an if. And then. Campaign category contains auto more. So what it will do is it will, from this list, find all the fields that contain auto more. And what do you want it to do? You want it to throw automotive. So what will happen is it will go and check a first convert and then check the campaign category if it contains auto more. It will convert it into automotive. Similarly, if you go and check, like after that, if campaign category contains com, then communication, campaign category contains tech, then technology is. Always, if is always stacked with an else. So else is lower campaign category. Let's return campaign category. Nothing matches along the line. So how do we do that? We go to dimensions, we go to calculated dimensions. And choose this. So in my file I have kept like two things. So how it looks like basically. I think I created a pivot for you. So how it looks like in the data stream, is technology, technological techno, automotive, 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 auto coming up. So what we do? We know that. What I need to do is I need to classify my campaign category. Right. And so what happens is you go to camp. There's you select campaign category. There is a pane which lets you select the type which is text over here. And there is something called a related measurement. Related measurement. I'll show you what is a related measurement. But just to keep in mind, related measurement is nothing, but it adds context to your calculation. Okay, so if I have suppose I put the related measurement to be campaign key, what will happen? What will happen is it will compute, keeping campaign key as a context for its calculation and per campaign key to do its calculation. This is a dimension thing, but if it is involving any sort of measurement, that needs to be sliced and diced. So a contextual measurement helps, it helps us with that. That functionality in any contextual thing will be like will be helpful. In case we want to do, we can add a contextual measurement, which will be related, and the calculation will happen keeping this context in mind. Okay, so what do you do? So the best part is, you can go over here and if you're doing an if. So you can choose this from here and if you just click on, if you will see that below, it tells you what this function does for you and you can drag it off and there and you can write the function. So, if and then, I want, like all my data to be normalized. So to normalize and use a lower function. And then campaign category contains auto, then automotive. If campaign contains com, then communication. If campaign category contains tech, then technology, else campaign category. Simple function, right? So how does it help us? This is before without uniformity. Which gives me a total of 8,366. And this is after it gets uniform, right? This is basically the calculated dimension that I have used over here in order to get the data. And I see that it works perfectly for me. So technology in automotive, which gives me this data, which was previously scrambled around like anything, but the data is correct. Okay. So yeah, so this was the first example that we see, and then once we are done with it, like before it was spread all across. Right, but when you categorize and when you do a uniform thing, this gets uniform and this gets categorized accordingly. Makes sense. That's cool. The second is extraction. So, like I'm sure people are familiar with the extract function. So what we do is we create new dimensions based on existing dimension values. So what we do is we over here from our existing dimensional values, we use the extract text function and we extract some parts of the data, which we think is relevant to us. Okay, so now you have your media by name, which has, the delimited values in it, which basically has some meaning, right? High gear, W, and everything has a meaning to it and everything is relevant to a single, dimension which is relevant to a single column. Oh, so what you could do is, you can go ahead and you have this delimited value. So there is one function called extract, and then your motive is to extract the first position of your media by name, so that this first position of your media by name can be a single partition, can be a single dimension altogether when you extract it and you can use it for your various calculations and stuff. Okay, so pretty simple function is extract. Extract media by name. And you put, put the delimited place which is underscores, because we have underscores over it. So what you do is underscores and comma 0. Okay, so why 0? Because in data indexing it begins from 0. So it is 0, 1, 2, 3, 4. Right, so the first position is referred to as index number 0, which basically what it does is, it extracts your first position of media by name and helps you do it. So that's pretty self-explanatory. And, once you have that out, you can use it as part of any filter and horizontal graphs or anything. So this is pretty clear, right? Yeah.